Good morning and welcome to Thursday, April 2nd for AP Statistics. Today is going to be a review day and there will be a homework assignment, but rather than have you complete it and hand it in today, I'm just going to ask you to work on it and be done with it for tomorrow, and I'll post the answers to the assignment. It is a practice test for Chapter 10. So let's do a little review here. All right, Chapter 10 itself was confidence intervals and hypothesis testing for two samples, and it was obviously proportions and means. So let's do a quick review here. For the two sample proportions as well as for the two sample means, there were consistent conditions. So let's review the conditions. All right, what are the conditions? Well, SRS, or some degree of randomization, and the 10% rule, which means our sample has to be no more than 10% of the population. And for proportions, we had NP hat and NQ hat being at least 10, and that was only for proportions. But if it was a means prompt, we had a population that was normally distributed, or a sample size of at least 30, or no strong skew seen in the sample data. Obviously, it breaks down proportions versus means. Don't use proportions conditions for a means test and vice versa. They don't belong, and that will make you lose some credit. All right? It's important that you are looking at both samples. So everything here has to apply to both of the samples in the two sample test. It's not good enough if only one of the samples meets the condition. They both need to meet for all of them. All right? Remember how the three-tier condition for means works. If the population is known to be normally distributed, you can end there with the normality condition. If not, you want to make sure your sample sizes are both at least 30. If that's not the case, you have to make sure that there's no strong skew or outliers in the data, in the sample data, I should say. And if you can't verify any of that, you can't continue. All right, so those are our conditions. Now, let's take a look at how we actually create our confidence intervals. So next will be our there you go. Confidence intervals. How do we form them? For proportions, it is, anyone, p hat sub 1 minus p hat sub 2 plus or minus critical z-score times the square root of p hat sub 1 q hat sub 1 over n sub 1 plus p hat sub 2 q hat sub 2 over n sub 2. Okay, all that information would be given to you only knowing two things: the sample size, that's n, and the number of people in the sample who gave a favorable response, that's your x. X over n is p hat, and it all goes down from there. All right, well, what about the means confidence interval? How do we create that? X bar sub 1 minus x bar sub 2 plus or minus critical t-score times the square root of standard deviation of the first squared over its sample size plus standard deviation of the second squared over its sample size. What is standard deviation squared called? That's right, variance. Good for you. How do we find critical z? Well, we should know by now what the standard critical z-scores are, but if not, inverse norm is the function. The area is 1 minus your confidence level divided by 2. 0 and 1 would be the mean of the standard deviation. How do we find critical t? Inverse t, where you again have 1 minus the confidence level over 2 is your area, and then you want to tell it the degrees of freedom. There's two sample sizes, so how many degrees of freedom do we use? The conservative estimate says it is 1 less than the smaller sample size. Okay, great. So far, so good. I thought so too. And now we have our equations and review for our hypothesis tests for the same. We'll say HT for hypothesis test. I like those initials. Anyone can tell me why? They're my initials. Hypothesis testing for, we'll do props over here. What's the formula to find a hypothesis test? We have to find our Z statistic for our sample data. Our Z-score for the difference is equal to the difference of the sample proportions, p hat 1 minus p hat 2, divided by the square root of, and this is where we come into the p hat combined, q hat combined over the sample size of the first, plus p hat combined, q hat combined over the sample size of the second. That's how we find our Z-score for the difference, and from there you want to use your normal CDF rules and function to find the area under the curve. How do we find p hat combined? Well, remember that p hat combined is just x1 plus x2 over n1 plus n2. That's the sum of the number of successes over the sum of the sample sizes. And then we have our means, of course. How do we find our t-score for the difference? Well, it's similar to what we've always been doing. It's the difference of the sample means, x bar sub 1 minus x bar sub 2. Don't forget, minus mu sub 1 minus mu sub 2. If there is a presumed difference, that's where it goes. Usually we presume no difference, so that whole quantity is the number 0, so we don't worry about it. And the denominator is the square root of s squared sub 1 over n sub 1 plus s squared sub 2 over n sub 2, as it was before. From there, we use TCDF, and we want to use our t-score for the difference as our boundary, and we also want to use the degree of freedom. Don't forget, for two-tail tests, we have to double the p-value. The context should tell you whether it's a one-tail or a two-tail test. Be very careful with that. We compare our p-values to our alpha levels. We reject the null when the p-value is lower than alpha. We cannot reject the null when the p-value is greater than alpha. Make sure that you always use context and in your example. Never say, we accept the null. We can't do that. We can either reject the null or we cannot reject the null. All right. Well, so far as a brief review goes, that looks like the brief review that I'm willing to give. I'd like you to work on the chapter test. That's on page 666 through 668. 10 multiple choice and a couple of open-ended. All right, I want you to practice with those. It'll review the concepts. And again, today is Thursday. I'd like it to be done for tomorrow by the time that I post the answers. But again, I'm not looking for you to submit this one. I'm going to give you the answers with some solutions worked out, and I'm hoping that you can either review it independently or you can ask me when you have specific questions. Please remember, I also offer to give anyone who needs a one-on-one phone call to talk about your Chapter 9 tests or any issues you're having in this unit. Just let me know, send me an email, and I'll make time for you. That's all for today. Have a great day.